Okay, so on this question, we've got an ln. That's just a natural log. It's the same rules apply. It's just a special kind of logarithm with the base of e. I'm not going to write in the e or do anything with that. Just know it's a logarithm. So it follows all the same rules as logarithms do. Okay, so what do they want me to do? They want me to take this one natural log and break it into 3 natural logs. How do we do that? Well, we use the 3 log properties. So there they are. There's the 3 log properties. And specifically, what do they say? 1 log can become 2 if multiplying in the 1 becomes adding between the 2. Or 1 log can become 2 if dividing in the 1 becomes subtraction between the 2. And then finally, 1 log to 1 log, the power can drop down to the front whenever you have powers. That's just 1 log to 1 log. So those are the 3 log properties. Basically what they're saying is harder, I think of multiplying and dividing as harder operations, and adding, subtracting is easier, right? Adding, subtracting was what you learned when you were just a young child, and then multiplying and dividing when you got older. So basically 2 logs make the operation easier. Like 2 people make a job, something easier to lift. You have 2 people. That's basically what we're saying. It's a harder operation, multiplying or dividing, harder for 1 log, 1 person, becomes easier when you have 2 logs. It just becomes adding and subtracting easier. It's no longer multiplying, dividing, right? And then property 3 is just about powers come down to the front for 1 log. Okay, so there's the log properties. Let's do it. Getting back here. So first off, you want to think about this like this. Oh yeah, this is a tricky one, isn't it? Okay, so this one's got some tricks for sure. So we have x to the 8th, and then this big old square root thing, and they're right next to each other. You don't actually, let me do the root thing first. Keep debating what to do. Let me show you the root property. So down here, let's talk about the root. Before we do the log thing, let's talk about the root properties. What is that? When you have a root, it can become a fractional power. Roots are fractional powers. There are 2 ways to say the same thing, like 1 and uno, roots and fractional powers. So how does it work? Whatever is in the hook, that can jump down and go into the denominator, become a fractional power, and the root vanishes. When you take that number out of the hook and swing it around to the denominator, the root vanishes. So you can turn a root into a fractional power, or vice versa, depending on what you need to do at the moment. So on this one, I'm going to take this fractional power and turn it into a root. Now notice there's nothing in the hook there. There's no number in the hook, but there's really an invisible number there. What number is invisibly there? Well, what do we call this? We call this a what root? Do we call it a quadratic root? What do we call it? A square root, huh? Don't we say this thing is a square root? And what does square mean? 2, right? This is called what? X2'd? X squared. Square is a word for 2. What's the word for 3 in math? What do we call this? X what? X3'd? Cubed, huh? This is squared, right? Third, why I say that? Well, because a cube is 3-dimensional. The square is flat, 2-dimensional. Huh? So 2 is a shortcut word for square. I mean, square is a word for 2. Cube is a word for 3. So what's my point on that? There's really a 2 here in that hook. Why? Because we call it a square root. We're saying 2 root. It's a 2 root. So basically, if they don't show anything in the hook, it means there's an invisible 2 there. It's a square root. If they put a different number, then great, it's that number. But if they put nothing at all, so it's the only understood 2 I know of in math. There might be something I don't know about, but as far as all the math I know, it's the only invisible 2. All the rest are invisible 1s, aren't they? Or maybe a 0. But this is an invisible 2. It's a square root. Okay, so who cares? Well, what I'm saying is when you have a denominator in a fractional power, when you have something in the hook, that can swing around and become the denominator, can't it? It can become a fractional power in the denominator. So let's get back to it then. I'm going to take this 2 and he's going to swing around and go right there and right there. Why both of them? Because the root is over both of them, isn't he? That root is over that whole fraction. So he becomes the denominator power for both of them. So this is going to equal natural log x to the 8th. And now we're going to have y to the 19 halves over z to the 2 halves. Everybody see what happened? And no more root, no more root. That's the whole point of the root property right down here, right? That if you have a root and you take whatever's in the hook and you swing it to the denominator to make it a fractional power, then there's no more root. So that's exactly what I did here. I took that 2, that invisible 2, if there's nothing in the hook, it really means 2, it's a square root. And I swung it to become the denominator of everybody it is over. The root is over both of them. So he'll become the denominator in the power for both of them. Like that, right? And then 2 over 2. I can just change that. 1. Huh. Because 2 divided by 2 is just 1. Maybe I shouldn't have done that. Maybe I should just go like this. Cancel it out. And it's 1. Yeah, there we go. Right? 2 divided by 2 is just 1. So, okay, so what now? So now there's no more root. I got rid of that root by swinging what's in the hook to the denominator of all the fractional powers. Okay, so now we can use the property to break this up into several logs. We could say this is ln of x to the 8th plus ln of y to the 19 halves minus ln of z to the 1. Now, do you see why that happened? Because of the fact that this is times, right? So that became adding. And this right here is divides, so that became subtraction. So multiplying becomes add, and dividing becomes subtraction. That's what the properties say right here, right? Multiplying for 1 log becomes adding for 2. Dividing for 1 log becomes subtracting for 2. Easier operation for 2 people, harder for 1. Easier for 2 logs, harder for 1. So multiplying, you might say, how'd you know they're multiplying there? Well, they're right next to each other. Whenever you have 2 things right next to each other with no symbol in the middle, it always means times, doesn't it? So there wasn't really a dot there, but I put it there for emphasis and clarity. It really means times. So times becomes adding for 2 logs. And then dividing becomes subtraction for 2 logs. So 1 log is now broken into 3. The times become added, the divide becomes subtract. One more step. Now, finally, we take log property 3. It says powers can drop down to the front. From 1 log to 1 log, powers drop down to the front. I'm going to do that. Say, oh, okay. Okay. So now just grab this this 8 power and drop him down. So it's going to be 8 ln x. Grab this 19 halves and drop him down. 19 halves ln y minus, don't forget this minus sign here. And then this 1 power will drop down to the front. Like that. See what happened there? And now we can identify our A, our B, and our C, right? A is 8. B is 19 halves. And C is -1, isn't it? Because that's what they said. They said, take this logarithm and break it into this form. We did, and let us know what A, B, and C are. And so we did. And so there we go.